Good afternoon. Today we will be talking about section 3.1, lines and transversals. So when we think about lines, we have a couple different kinds of lines that we studied. The first kind is parallel lines. And parallel lines are two, or technically two or more lines, which are coplanar and do not intersect. So probably when you look at this definition, the most important word in this definition is going to be coplanar and the fact that they never intersect. So they actually have to lie in the same plane. We also have parallel planes, and parallel planes are two planes which do not intersect. So this would be like the ceiling and the floor, or it could be something like the left wall and the right wall. So two planes which extend forever and never intersect. We also have skew lines, and skew lines will be two lines which do not intersect, but they are not coplanar. So skew lines are not parallel because they actually lie in separate planes, but they also never intersect. So the best example that we can use to model these is a picture of a cube. So if we look at this cube, you might need to take your picture and just note it's a little bit dark, that this back intersection point is point F. So there's a little F back there. It's really hard to see on your all's picture. But what we want to do is we want to come in and we're going to name all the segments that are parallel to segment AH. So if I come over here and I look at my picture and I look at segment AH is on this front right hand side. And I think there are 4 segments that are parallel to AH. So if I look to the left, I have a segment right here, which is going to be segment DE. So we have segment DE. Don't forget to put the little segment mark over it. On the back right, we have segment BG over here on the back right. So we have segment BG with the correct symbol. And in the back corner, we also have segment CF. And all those lines, or all those line segments, are parallel to line AH. So now we want to give 2 examples of parallel planes. So if you think back to Unit 1 and we think about how we can name a plane, it takes 3 letters to name a plane. There are multiple examples of parallel planes in this diagram. So if I take the front plane, I have the letters A, D, E, and H. And if I want to name that plane, I'm going to pick 3 of those letters. So you can pick any combination of those 3 letters. So plane ADH is going to be parallel to the back plane, and the back plane contains letters C, B, G, and F. And so I don't care which letters you pick out of those, but to name a plane, you're only going to use 3 letters. So maybe I will choose C, G, and F. So those 2 planes are parallel. That would be one example. Now, if I look at the top of the box contains points C, D, A, and B, and the bottom of the box contains points E, F, G, and H. So when I go to name those planes, I'm only going to pick 3 letters. So maybe I pick D, A, B for the top plane. And for the bottom plane, again, pick any 3 of the 4 letters. So maybe this time I go with F, G, and H. And know that order is not important. If you wanted to, you could have also used the left side and the right side. All right, so example C. Name 2 segments skew to segment FG. So if we look at where segment FG is on this picture, segment FG. FG is this segment along the back side. So we cannot use any of the segments that are parallel to that. So we need to look at segments that do not intersect but are not in the same plane. So one example might be this line up here, CD. You could use AB. You could use AH. You could use DE. So any of those would be examples. So segment CD would work. Segment DE would work. Segment HA would be an example, and segment AB would also be an example. I think the remaining segments would be parallel, so they would not work. All right, So if we talk about parallel lines, if you have a point, like we have point P in this picture, and we have a line A, how many different lines can you draw through point P that are parallel to line A? So take a minute, and I want you to draw all the lines you can that go through P that are parallel to point A. All right, so let's talk about how many lines you drew. So if you drew this line, you're good. And I look at this, and I don't know that I can draw any other lines that actually go through point P that are parallel to A. And that's exactly what the parallel postulate says. The parallel postulate says if there is a line, so we had a line, and we had a point not on the line, then there is exactly one line that goes through the point that is parallel to the given line. So any other lines we draw either wouldn't go through point P or they would not be parallel. This brings up the perpendicular line postulate. So similar scenario, we have a point P and we have a line A. So I want you to draw as many lines that go through P that are perpendicular to line A as you can. All right, again, if I accept this challenge, I think most of you probably got this line right here, and I would mark little right angles there to verify that that is perpendicular. And I don't know that I can draw another line that's perpendicular in two-dimensional geometry. So the perpendicular line postulate states that if there is a line, so we had our line A, and a point not on our line, which was our point P, then there is, again, exactly one line that goes through the point that is perpendicular to the given line. All right, so as we start our study of lines and angle pairs, we first must determine what a transversal is. And a transversal is a line which intersects two or more coplanar lines at different points. So a transversal is a line which intersects two or more coplanar lines at different points. So if I look at this picture, which you also have on your paper, if we look at this particular picture and we think, okay, hey, I got a transversal, this right here is my transversal. This line T intersects two or more lines at two different points. Now, transversals form special angle pairs. So we are going to go over the 6 types of angle pairs formed by transversals. And once we have these down, the rest of the chapter will be relatively simple. So basically, just look at the vocabulary. So when we think of my transversal, and I'm going to re-highlight it here. So here's my transversal. We have interior angles and we have exterior angles. So when I think about what defines interior angles, angle 2, 6, 3, and 7 are interior because they are between my two coplanar lines. Whereas angles 1, 5, 4, and 8 are all exterior angles because they are outside of my two coplanar lines. When you look over at the words alternate interior and alternate exterior, the word alternate means they are on opposite sides of the transversal. So when we think about alternate interior angles, they are on opposite sides of transversal. So opposite sides of the transversal. They are interior and they are at different intersections. So if I look on this picture and I think about alternate interior, I have angle 2 and alternate interior. It's going to be opposite side of the transversal and interior, so that leaves me with 6 and 7. And then the fact that it has to occur at a different intersection leaves me with angle 7. So angle 2 and angle 7 are alternate interior angles. And then I could also look at angle 3, it's interior, so angle 3 would be alternate interior to angle 6. So I could also use angle 3 and angle 6. So the definition for alternate exterior, very similar, only one thing changes is these angles are exterior. So they are on the opposite side of the transversal. But they are exterior, and they are also at different intersections. So if we look at the picture and we determine, all right, we want to name some alternate exterior angles. I have angle 1, and I'm going to come down to the bottom intersection. I need an angle on the opposite side of the transversal that's exterior on the second intersection. So when I look at this, I have angle 1 and I have angle 8 that are alternate exterior. And then if I look at my picture again, I have angle 4 right here. And if I come up to the top intersection, I have angle 5, which is on the other side of the transversal and is exterior. So I can look and say that angle 4 and angle 5 are alternate exterior angles. All right, perfect. Same side angles are on the same side of the transversal, but they are adjacent to different lines. So they are also at different intersections. However, they are on the same side of the transversal. So again, I'm going to highlight my transversal so that my transversal is obvious. So here's my transversal T. And so now when I look at same side interior angles will sometimes be called consecutive interior angles. So if I look, angle 2 is interior, and I need another angle that is on the same side of the transversal that's also interior. So if I look at this picture and I think, okay, I need another angle on the same side of the transversal that's also interior, I get angle 3. So angle 2 and angle 3 would be considered same side interior. If I go the opposite side of the transversal, I have angle 6 and I have angle 7. So they are on the same side of the transversal and they are both interior. So angle 6 and angle 7 would be considered same side interior angles. So now if I flip over to same side exterior, I have the same conditions except for their exterior. They're on the same side of the transversal, but they're exterior. So angle 4 would be on the same side of the transversal as angle 1. So angle 4 and angle 1 would make a pair of same side exterior angles. And I look at what's left and I have angle 5 and I have angle 8. They are on the same side of the transversal and they are both exterior. So angle 5 and angle 8 would be considered same side exterior. Corresponding angles. So if we look at definition, corresponding angles have corresponding locations. So when I think of corresponding angles, I think of their location like by an intersection. So like if you think of 119th, so if this is 119th and this line here is western, okay, there's actually a mid-first bank right here. But if you go to 104th and Western, there's actually a Taco Bell over here at 104th and Western. So if we think about those are both on the northwest corner of the intersection. So these would be considered corresponding. So angle 3 and angle 1 would be considered corresponding. They have the same location, but at different intersections. So let's look at angle 4. So now you have angle 4, and I want to go up to the top intersection, and I want to think, okay, what angle, 2, 5, or 6, has the same location at that intersection as we have at the bottom intersection? I can think of this as the bottom left angle is angle 4. So if I look at the bottom left angle here, that would be angle 2. So angle 4 and angle 2 make up another pair of corresponding angles. So now there are 2 more pairs of corresponding angles. Up here at the top, I have angle 5. So I think this is the top right angle. And down here, I have the top right angle of this intersection. So angle 5 and angle 7 would be corresponding. And in the end, that leaves angle 8 at the bottom right, which coming up to this other intersection, if I look, angle 6 is also at the bottom right. So angle 6 and angle 8 are corresponding angles. All right, so let's look at these examples. Here in example 1, we are going to name the transversal or write no transversal. So let's look at angle 13 and angle 10. So if I look at angle 13 and I look at angle 10 touches W here, and angle 13 touches W there, so that means that W would be the shared transversal. 2 and 11. So let's look at 2. So here's angle 2, and here's angle 11. So angle 2 touches right here, and angle 11 touches right here. So 2 and 11 share transversal Y. So take a moment, hit pause, and do C, D, and E on your own. Remember, if there's no transversal, to write no transversal. All right, welcome back. So let's look at angle 7 and 14 together. So down here we have 14 and over here we have 7. So if we come along here, they both share that transversal, which would be transversal Z. Angle 16 here and angle 12 right here. Those look to share this line right here, which would be V. And last but not least, we have 2 and we have 7. So here's 2 and here is 7. Well, 2 touches Y and 2 touches W. 7 touches transversal V and 7 touches transversal Z. So here they have no transversal in common. All right, moving on to example 2. So we want to name the angle relationship. That would be alternate interior, alternate exterior. So let's tackle a few of these. So let's look at angle 1 and angle 6. So first of all, I need to decide if they're on the same side or alternate sides of the transversal. So if I look at transversal W, they are on all opposite sides and they are both interior. So I would call these alternate interior angles. All right, let's look at 3 and 15. So here's angle 3 and here's angle 15. They share transversal V. They're both on the bottom left and one's interior and one's exterior. So they can't be interiors and they can't be exteriors because I have one of each. But since they hold the same location, this is on the bottom left and this is also on the bottom left, that means those are going to be corresponding angles. Okay, 14 and 10, we'll do one more together. So 14 is down here on the bottom right. And over here we have 10. And if we think of this as transversal W, they are both exterior and they are on the same side. So we will consider these same side exterior angles. So I want you to take a moment and I want you to do problems D, E, F, and G on your own. So hit pause, and when you are finished, hit resume, and we will go over your answers. All right, welcome back. Angle 2 and 11. So if I look at angle 2 and I look at it 11, compared to this transversal right here, they are interior and they are on opposite sides. So these are alternate interior angles. Angle 5 and angle 14. So here's angle 5 and here's angle 14. They don't share a transversal, but I know from the previous units that those are an example of vertical angles. Angle 8 and angle 13. So here's angle 8 and here's angle 13. So angle 8 and angle 13 share transversal V. They are exterior and they are on opposite sides. So those are going to be considered alternate exterior angles. And then I'm going to look at angle 3 and angle 10. So angle 10 is right here and angle 3 is right here. So angle 3 and angle 10 compared to this transversal right here, transversal Y, those are interior and on opposite sides, so those are going to be considered alternate interior angles. All right, moving on to example 3. All right, so I want you to look at the picture and I want you to name 3 pairs of alternate interior angles, corresponding angles, and same side exterior angles. And I will have the answers in class tomorrow when you get there, and we will be ready to discuss these. Have a great night.